Looks like it is. Yeah, stop. Okay, so Pythagoras theorem. I can use what type of triangle can I use on them? Right angle triangle. When do I use Brianna?
When you want to find one side.
Yeah, when you know two sides of a right angle triangle and you're looking for the third side. Okay. So here up here on the board, so I use Pythagoras theorem when it's two things. I have a right angle triangle, and I know two sides, and I want to find a third. So here in this example here, let me know if you can't read the writing because it's pretty crap. Here I know this side and this side Edel. Let's just label them first. Let's pretend this is the angle we're dealing with. The side opposite the angle is called what, Dylan? Opposite. This fella here, Brianna? Adjacent. Adjacent, yeah? And then the side opposite the right angle is always called what, Edel? It's always called the hypotenuse. So the side opposite the right angle, Edel, is called the hypotenuse. The side opposite the angle, so here's my angle, and right opposite that is, and this is called my opposite, and that's supposed to be OP. And here, the side along the angle is called the adjacent. That's supposed to be AD, if you can't see that. So then Pythagoras' theorem is hypotenuse squared is equal to adjacent squared plus opposite squared. Okay, what happens if you don't know that formula? Or do we know that formula off the top of your head?
Yeah.
Okay, well it's here in the log tables, kinda. See here, instead of hypotenuse to call it, so we're down here at Pythagoras theorem, instead of hypotenuse to call it C, instead of opposite to call it A, instead of adjacent to call it B. Do you see that? You okay with that, Dylan? Brenna? So if you forget it, it's there. Are you okay with that? Right, so on page, if you want to make note of that, page 16, it's log tables. Do you find it hot in here? It was roasting here last week, though, wasn't it?
Yeah.
It's so hot. Right, okay. So let's hypotenuse squared is equal to adjacent squared plus opposite squared. Let me try bring that up a bit. So here, all I do is I kick out my hypotenuse Edel and I stick in what? Okay, no. Forget about the square. Just deal with the hypotenuse bit. So I kick out. Pretend the 2 isn't there. I kick out hypotenuse and I stick in x. Where did the x come from?
From the angle.
Because the hypotenuse here is x. And then I square it because that's squared equal to. I kick out adjacent and I stick in what, Dylan?
4.
4. And then kick out opposite and I stick in what, Brianna? 3. And then I say x squared is equal to 16 plus 9. Do you know where these numbers came from? 4 squared is equal to 16. I add them together, I get, let's stop moving my mouse, I get 25. X squared is equal to 25. How do I find x, Dylan? Yeah, square root 25. You okay with that, Edel?
Yeah.
See, this is x squared. It's x squared here, but we only want what x is. So we get the square root of x equals square root of 25. So x equal to what? 5. Yeah. Will you ever go with that one there now without looking at the answer? So here, that one there on the board. Do you have paper? Dylan, do you want paper?
Yeah.
Here, just use it and rip out what you. Do you have Pyro?
Yeah.
Yeah. Sorry, there should be a little. Should put that in there first. It should be a right angle triangle. Something hairy moving in there at the side of the screen. It was you, Edel. So you okay with labelling it? Yeah, you all know what the hypotenuse is, Edel?
Yeah.
It's the side opposite which?
Opposite.
The right angle.
Right.
The hypotenuse is always opposite the right angle. Yeah. You're happy enough with that, then? Yeah.
Yeah.
Yeah. What happened, Brianna? 25 minus 1 is 16, I think.
Oh,
Yeah. Are you getting on either? Yeah. Just one small thing, the square is outside the bracket. It's going to be the same thing. It's just something small. Just check this for a sec. Yeah, I'll see it. Yeah, you're going right though. So what you do then, you probably have, yeah. Here, so x squared. Wait, finish off there a bit. So here we have, sorry, 25 minus 9 is what? 16, I think. 16 is equal to x squared. That means that x squared is equal to 16. Would you agree with that?
Yeah.
How would you find x?
X is equal to.
Okay, x is equal to the
Oh, yeah,
square root of 16, which is what? 4.
Mm.
You okay with that?
Yeah.
You sure?
Yeah.
Okay. You okay with that one? You all got x equals 4 in the end.
Yeah.
Right. Let's move on to sine, cosine, and tan. Did you ever see this thing? Silly old Harry caught a herring trolling off America. Yeah. Do you know what it means? Yeah. Brianna? Okay. So, do you know what off the top of your head? Silly old Harry caught a herring trolling off America. I'm not going to make you sing it or say it. So what it's useful for Edel is see up here on the board, Edel? Do you know this, Edel? Did you ever see it before?
No.
Did you not? Did you hear something like, I can't even think of the other ones. Oh hell, another hour. No, that's something else. Oh hell, another hour of algebra. Did you ever hear something like that?
Yeah.
Was that it?
Yeah.
Right, okay, I forget that one. Oh hell, another hour. Right, this is just silly old Harry caught a herring trawling off America. It's the same idea, Edel. So what you do is you take the first letter from each word, so it's S-O-H, C-A-H, and T-O-A. See that? S-O-H, C-A-H, and T-O-A. Are you all okay with that? Group them in threes. So the S here, Brianna, stands for sine, equals O stands for opposite, and H stands for, what do you think? Hypotenuse. O goes on top. Opposite goes on top because it comes first. Opposite over hypotenuse. C, what do you think C stands for, Edel? Cos of A is equal to what, Dylan? Adjacent over hypotenuse. And remember, A comes first, so he goes on top. And T stands for tan, equal to what, Brianna? Opposite over adjacent. And this little rhyme, or this little saying, is just a way for you to remember this. Are you all okay with how it works? Do you have any questions on it? No? Right, so when can I use this? Anyone?
You want to find an angle and a triangle.
Yeah. I need a right angle triangle, and for you it will always be right angle triangle. And I need to know one side and an angle, and I want to find another side. Okay, so that's a lot to take in. So go on to the next page. So I need to know one angle, one side, one angle, and the one I'm looking for, what, Brianna? Another side. You okay with that, Edel? Right, here, this example here, find x. Okay, so the first thing you always do, check, can I use Pythagoras' theorem? Can I use Pythagoras' theorem here, Edel? Sorry?
No.
No, why?
Because it's used same.
Okay, well, why can't I use Pythagoras' theorem?
Oh, because it's.
What?
It isn't right.
It is a right angle. Go flick back to the front page there and see when do you use Pythagoras' theorem. You need to know when you can use them and when you can't.
When I have more angle and you know the two sides and you want to find
What am I missing there? read it out there again. What's the first thing I need to know? Is it a
Right angle.
is it a right angle triangle, this fella?
Mm,
Yeah, how do I know that?
because of the
Little L there, thing there. Can I use, okay, what did the second thing of Pythagoras' theorem say?
and I know two sides and I know try to find.
Okay, stop. Do I know two sides of this triangle?
Yeah.
Okay, name them.
7.
No, see, I don't know x. I only really know 7, don't I?
Yeah.
Yeah. So can I use Pythagoras in here, Brianna?
No,
No, why?
because only one side.
Yeah, I have only one side. So that rule. So what you do with process elimination, you rule him out. So then I go to silly old Harry, caught a herring trawling off America. Okay, I need to know. This is the confusing bit. Do I use sine? Do I use cosine or tan? Would you agree with that? Okay. I'm going to write out what do I know, what do I want, and that will give me my formula. Now, no means side or sides. Let me just write that in. No, when you're talking about no, what do you know? You're talking about a side or sides. You're never talking about the angle. If you want to just scribble that in. Now I know you might do it a different way. So when I'm talking about no, Brianna, I'm talking about a side of the triangle. What do I want? This could be a side or an angle, depending on what we want, okay? We'll come to that one in a second. So want means side or angle. Right. So let's look at this triangle. What do I know, Brianna, in this triangle?
That the hypotenuse is 7 and the angle is 30.
Okay, no, what does no mean?
Oh yeah.
Side or sides. Okay, so I know, so basically what you said, I know the hypotenuse. Yeah?
Yeah.
What am I looking for, Edel, in this? Adjacent, so I write adjacent down. Now what I do, see this H and A. I go to my silly old Harry here and see where's A and H in that. So is A and H there?
No.
No, he's not him. A and H here? Yeah, so that means I use cos. And this is the way I always did it and find it easy enough to figure out whether to use cosine or sine or tan. You okay with that, Edel? So why did I pick cosine?
Because the CAH is strong.
Yeah, exactly, because I'm dealing with the H and I'm dealing with adjacent, and this is the only place where hypotenuse and adjacent is, so it has to be cosine. Are you all okay with that?
Yeah.
Yeah? Do you find that easy enough?
Yeah.
You sure? So no want formula. So I know that the cosine of A is equal to adjacent over hypotenuse. Where did that come from, Dylan? Yeah, silly old Harry, caught a herring. Cosine is equal to, why do I put adjacent on top, Edel? That's the formula, because A comes first here, and then hypotenuse goes on bottom because H comes second. Are you okay with that? Now all I do is just sub in. Okay, sub into this formula. So what does my A stand for? Maybe I'll write that in. What does my A stand for here, Brianna? The angle. Okay. What angle is in this triangle? What angle am I dealing with in this triangle? 30. So do you see what I did there? I kicked out the A, Edel, and I stuck in 30. You okay with that? Equal to, I kick out my adjacent, and what was my adjacent to the triangle, Dylan?
X.
X, so I stick in X. My hypotenuse, Edel, I kick out my hypotenuse and I stick in, where does the 7 come from? Yeah, show it to me there on your page. Yeah. You all okay with that? Are you all okay with that step here? Okay. Are you sure? Right. So now here is where it might be a little bit confusing, and I can do it a different way. When I have a fraction equal to a fraction, what can I do? Do you remember this from the first day doing cross multiply? So do you see that, Edel? If I have something like this, if I have 1 all over x equals 2 all over 3, how many fractions have I here on the left hand side? 1 fraction. Equal to, how many fractions have I on the right hand side? 1 fraction. If I ever have that, what can I do? Cross multiply. Are you okay with that? Right. So, okay, here's the question. Do you prefer working with decimals or fractions? Okay, because if you type it, have you a calculator? This is up to you now what you want to do. Sorry, I'll give you that. Go for growth today. Yeah. No. So how do you find? You find the cosine of. What we have to do is find the cosine of 30 on the calculator. Now what you do is type in cosine. First cosine. Cosine of 30. And just remember to close the bracket at the end. Okay, and we get root 3 over 2. So are you okay working with that, or do you want it in decimal?
Decimal.
Why, you don't like the root, is it? Or it's completely up to you.
Yeah, probably
Decimal. Okay, it's up to you. I prefer working with fraction, but it's up to you. So we'll go decimal for Dylan here.
And kind of like shorten term, or for it to go decimal.
See, that's why I like working with fractions, because you don't have to work out. It's see here at this part of the sum. It's a bit early to round it there, because your answer might be a bit off at the end.
Yeah.
That's why I prefer working with fraction all the way up until the end, and then round it. Are you with me? So if I was doing this, Brianna, I would say, would you just do cosine of 30 there, Dylan? Please? Sorry, let me add a new page. Page below. Okay, so I had. I think it was cosine. Could you call out that one to me? Cosine of 30, wasn't it?
Yeah.
Cosine of 30 equal to what? X all over 7, yeah? So you work that out, Dylan, and when you do the decimal.
Decimal.
Yeah, do the decimal one for me.
0.866.
Oh, here, I'll save you calling it out. 0.860254038 equal to X all over 7. So I'd write it all out, Brianna, until the real end. Okay, so then what's my next step here? Cross multiply. When can I cross multiply? Then I have what equal to what? One fraction equal to one fraction. Do I have that here? Okay, but really I do. Put it over 1, yeah? So then I cross multiply him by him, and all this fella by that. That's equal, X is equal to 7 times 0.866. I'm just being lazy here. 38. Pretend I wrote it all out. X is equal to. You just multiply that by 7, Dylan.
6.0621.
6.06. Yeah. 0.62177. Blah blah blah. The question, Brianna, might ask you to round it to whatever 2 decimal places. So that would be 6.06. Okay, but I wouldn't round up here at this part at all, because your question might be put off. You all okay with that?
Yeah.
You sure? Do you want to scribble that bit down actually, someplace? Danny, you have a book with you today? No. Yeah. My last hope, no. And if you have a number equal to a fraction, just remember we can always put a number all over 1 to turn it into a fraction. And maybe I'll just put an NB there for cross multiplying. So we'll nearly always be cross multiplying here. You all okay with that? Right, will you have a go at that first one there now? So remember, what your two checks so far is, can I use Pythagoras' theorem? And then if not, if I can't use Pythagoras' theorem, Edel, who do I go and think of?
Sin cos.
Yes, sin cos tan. And the important thing, actually I should mention this, the important thing is always label triangle. And if you're in an exam and you have a, just pretend you're in an exam here, okay, and you're given this on your exam paper. I draw out the triangle again on your own paper. Otherwise, if you make a mistake on that, you don't get a second copy. You know, if you have that messy, it might be harder for you. So maybe draw it out again, but here it's fine. Did you get the triangle labelled, Bill? Yeah, good. What's your one? Oh hell, another hour of algebra. Oh yeah. Oh hell, another hour of algebra in Costan. That's, yeah, okay. I remember. How are you looking, Brianna? Yeah, that way. Yeah, that looks right. I don't know the answer. It looks right. Yeah, no, you don't know the steps right. Have a go at the second one there as well. Does that no want formula thing help you any bit?
Yeah.
Yeah, does it? Yeah. I struggle with that as well. Didn't have a clue what to use, whether to use sine or cosine or tan or which one. It's good, he did. Yeah, that's right. This one is a little bit trickier. Oh no, is it? Well, it's not really. It's a little bit different. Yeah. It's 1. Tan 45 is 1.
Oh, just one even.
Yeah, just 1 even. Yeah, x equals 3. Are you okay with that? Can I just see that first, please? Did you all get x equals 19.12 or something like that? Yeah. Should be 1.3, sorry. 1.3 rounded to 2 decimal places. Yep. We happy to move on?
Yeah.
I'll let you away with that second one. It's just the same.
Yeah.
Right. this one, in this example, find angle A. Now this is a little bit different. I'll just put an NB here beside it, because this is a little bit different. Find angle A, right? So let's look at this triangle here. I'm looking for angle A. Can I use Pythagoras' theorem here, Adele? Why?
Because you don't know the two angles.
Okay, go back to Pythagoras' theorem there at the start on your page. We'll see. When can I use Pythagoras' theorem, Dylan?
The right angle triangle and
Yeah.
two sides.
And I'm looking for a
Third.
third. Can I use Pythagoras' theorem here?
Yeah.
Okay, what am I looking for? An angle. So Pythagoras' theorem is, I know two sides, Adele, and I'm looking for a third side. What am I looking for here, though? I'm looking for angle. Do you see the difference, Adele? Pythagoras' theorem would work if I was looking for adjacent, but I'm looking for the angle, so Pythagoras' theorem won't work. Okay? So then, you know the silly old Harry thing? This can be used to find angles as well, right? But the different thing. I can use this to find an angle if it's the right angle triangle, and if I know two sides of the triangle. Okay. What was the last one? What was the last one there, Dylan? When was the first time I could use silly old Harry? When I had a right angle triangle,
An angle and a side.
an angle and a side, and I was looking for
Another side.
another side. This time here, if I have a right angle triangle and I know two sides, and I'm looking for an angle, I can use silly old Harry as well. It's the exact same thing here, almost exactly the same. What do I know? What do I want? Give my formula. No means side or sides, Brianna. So what side or sides do I know in this triangle? Would you agree, Del? Yeah. What do I want? Okay, will you scribble? It shouldn't be formula. Will you scribble that out? It should be angle. I'm looking for an angle. Yeah. So then what I do is, see this H, I go to silly old Harry, caught a herring. So where's my silly old Harry? I didn't write it out. So let me write it out here again. So silly old Harry caught a herring trawling off America. So I look at which one of these has both H and O in it, Adele. Sine, sine. So that's where sine came from. So sine is equal to opposite over hypotenuse. Sine of an angle is equal to opposite over hypotenuse. Are you with me? Yeah. What does A stand for here in this case? So what we do is we fill in for what we know. What does A stand for? Angle. What's my angle here in this case? X, or yeah. Will we just leave it A? Yeah. We'll just leave it A. So angle A doesn't. My opposite then is, what's my opposite? Well, it's going to be 4. Where does this 5 come from, Edel? The hypotenuse. Right. Just be careful with this one now. What am I looking for here in this? I'm looking for the angle. Okay, put an NB beside this. If I'm ever looking for an angle, I use the shift button on the calculator. Shift sign button. Did you ever see that before? Yeah, shift. Yeah, it's called the inverse sign. So if I only use it when I'm looking for an angle, right? So I'm looking for an angle here, Edel, okay? So to get A on its own, I get shift sign of the other side. See what I did there? Dylan?
Yeah.
Yeah. Brianna?
Yeah.
Edel? Yeah. Okay. So what I did here was I sine of A is equal to 4 over 5. What am I looking for here, Edel? Am I looking for a side or an angle? Angle. So if I'm looking for an angle, I always use the shift button to find it. Okay? Did you ever see that before, Edel? So what I'm doing is, so what you do, you type, we're dealing with signs, so I press, hold on, where's, right, shift, sign, and then I type in 4 over 5, yeah? And don't forget to close your brackets. You okay with that? And that'll give me my angle. So 53.13. So A is equal to 53.13 degrees. You okay with that? So when you're using this, when you're using silly old Harry, the question you have to ask yourself is, am I looking for an angle or am I looking for a side? So it's either angle or side. If I'm looking for an angle, Edel, what button do I use in the calculator? The shift button. So here, we'll even go with this one here now, just to get a bit of practice in. Yeah, so the first thing you do in triangle is always label it. And if you're unsure, then you write out what you know, what you want, gives you a formula. This class over a quarter past, isn't it?
Yeah.
So, just think there for a sec. The sniffles you do.
Yeah.
What is it? Angle A is equal to
14 degrees.
yeah, 14 degrees. That's okay now then, but in a question just watch out for two decimal places or
Yeah.
the nearest decimal place or the nearest whole number. Just one thing here. See what you should always have, you should have A on the left. I know it's only a small thing. I'm not sure if you'd lose marks, I don't think you would. You alright, Brianna?
Yeah, so you put in shift.
Cosine and then 3 over 17. No, yeah,
What's your answer?
that's it, yeah. What do you get, Dylan?
14.03.
Do it there again.
Oh, I just like it.
So, what I was just saying to Dylan there,
Yeah.
cosine of A is equal to that. What I'd write down, let me just get that line. What you write down is A is equal to cosine inverse 3 over 17. Angle A is equal to 79 point.
Okay.
Yeah, sorry, did you say that?
Right.
It's only a small thing, but
Yeah. Okay.
yeah, okay. Otherwise, that means you're not finished yet.
Oh yeah.
Yeah, we better not be sick tomorrow. That's 1 to 2. Okay, so just into the rest of there. That's right. So you should look at this. Cosine of A is equal to 3 over 17. What you should write down, A is equal to cosine inverse of 3 over 17. A is equal to 79.835, blah 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 blah. Okay, so it should look at it. It should be A is equal to that, not cosine minus.
Oh.
That doesn't make sense there.
Okay.
Like all you're working is right, just to write it down properly. You all okay with that?
Yeah.
Right. Sine rule. That's not for ye. Yeah, I think we're done. That's why let me do degrees and minutes. That's why I was hoping one of you'd have a book. I think I need to know. So I'll just use the book online. So will you just look through them exam papers there and just... Jeez, they're fucking tiny. Junior search. Maths. 15. Open. Let's ordinate it out. Maths. That's your book, isn't it? Higher level. Active Maths book 2. Page. Sugar. There. Degrees, minutes, and seconds. 426. 426. Right, did you ever see this thing of degrees, minutes, and seconds?
Yeah.
Yeah, do you know what it's about, Dylan?
Is it when you press this button and change it? Time or something?
Yeah. I think do you have to do it without a calculator? I'm just checking to see do you do it without a calculator. Search. Okay, so let me please. Minutes, seconds. Joe, are you on the same class? No. Alright, okay. Who's your teacher?
Sarah.
Who? Miss Harry. Okay. 12.4 degrees. Let me let's fill up in. Lovely. Yeah, okay. So usually in a triangle, you see something like this as an angle. Tell me if I'm wrong. You see something like this, 12.4 degrees, don't you? Okay. So, you know, if you were talking about distance from here to Dublin, some Dylan might say, oh, it's 200 kilometres, and Brianna might say, no, it's 150 miles. Yeah? Well, do you see that they're kind of the same thing, except what's different about them? They're just different. They're just different units. Yeah, one's in kilometres, the other's in miles. It's the same thing here with these degrees and minutes. You could have a triangle with angle of 12.4 degrees, or you could have an angle of 12. Yeah, get the right answer. 12 degrees 12 degrees 24. Alright? Yeah, 12 degrees 24 seconds. It's going again, isn't it? 24 minutes. Yeah. You could have something like 12 degrees 24 seconds and 24 minutes and 0 seconds. Is that right? Okay, these things this just means this one here is in degrees, whereas this one here is in minutes and seconds. Okay, and what you have to be able to do is convert from one to the other, right? So how do you do that? I'm just trying to think. Can you do it with just a calculator? It looks like you can. Okay, let's do it on the calculator. So the first thing I'll do is, first question is convert 12.4 degrees to degrees and minutes. You know how to do it, Dylan? Yeah, so all you do is what? 12.4. Where's the DMS button? DMS.
Oh, equals
12.4 and then what? DMS then, is it?
There.
Yeah. Do you all see that? So I'll do it there again. 12.4 equals, then you press, Dylan will show you, GMS button, and it converts it into 12 degrees, 24 minutes and 0 seconds. You all okay with that? Yeah? You sure? Let me just try something. 60. Okay, do you know where that... I'm just trying to think, will it bother my time? Do you all have that same calculator?
Yeah.
Yeah. Okay, the second one then is convert 12 degrees 44, 12 degrees 44 minutes to decimal form. Okay, this is just going back the way. So 12 degrees minus 24. Oh, I forgot to put it at the end. 12 degrees. Okay, so see this one here, we're converting, convert 12 degrees 44 minutes to decimal form. And all you do is type in 12, the degrees minutes, 44, where are we? 44, and then you press degrees and minutes again. You press equals, and this comes up, and you press SD till you get degrees. You okay with that?
What is degrees of shoot minutes and seconds?
Huh?
What is degrees of shoot minutes and seconds?
It was got to do with years ago where I think was the world spinning around and the time it took. I think good question, Brian. I don't know. I really don't know. Yeah, I don't know why. I think it was something got to do with that. So are you all okay with that? I'm just trying to think. Is that it? I think that's it to it. Yeah. What was the third question there? Oh yeah. See here, question 3. Please below. Sorry, I was a bit slow. So what was it? If tan of A is equal to 0.7638, 0.7628, find A in find A to the nearest meter per minute. Right, okay, see this one here. Yep. If tan of A is equal to 0.7638, find A to the nearest minute. Right, what do you think you do here? Do you remember at the start, what are we looking for here actually, first of all? Okay, am I looking for a side or an angle, do you think? I know there's no picture of a triangle. But what does A stand for here in this case? Angle. So what am I looking for? Angle. When you're looking for an angle, what do you think you're doing on the calculator? What button do you think you're using? The shift button, yeah? So what I do here then is this case. Is this in, so I'd leave it all in degrees. I'd leave it all in decimal till the real end, and then I'll convert to minutes. Are you with me? So let's work this out. So A is equal to tan inverse of 0.7638. Would you work that out for me there, please? So A is equal to 37 point. Give me to 2 decimal places.
37.37.
Oh, sorry. Yeah, 37.37. Okay. Is this answer in decimal or minutes? Decimal. Could you just convert that to minutes for me now, Dylan? Yeah. So when I convert to minutes, A is equal to what, Dylan?
37 degrees, 22, 21 seconds,
20. That's enough. 22 minutes. I just asked for the nearest meter or nearest minute. So it's 37 degrees, 22 minutes. You all okay with that? You sure it's weird? You just need to know how to do it. You just need to know how to work it on the calculator. Any questions on that? Okay. Let's go do some exam questions. Yeah, let me just flick through the book there, make sure I'm missing nothing. Yeah, it was something got to do with that, Brianna, I think. Okay, that's. Yeah, let's do some examples. Let me open up. So this junior search exam questions. What's that angle there actually?
40.
Why?
Kelvin
It'll be 90, yeah. Do you see that, Brianna? You tell? 90 degrees. Come on, open. Oh, there it is. Where'd you go? Annoying. Okay. So we'll just talk through these for a moment. So this one, use your diagram on the right to calculate the value of x. Give your answer in third form. What does third form mean? Yeah, it means your answer, if you want to write that in. I'll help you through these. It just means your answer will be, your answer should have a square root in it. Sorry, I know you need a magnifying glass to see these. Yeah, you okay with that, Brianna?
Yeah.
Right, how would I find x there, Brianna?
Your hypotenuse, the liquid algae.
Yeah, so what's that called? Pythagoras theorem, okay? Use the diagram below to calculate the value of y. Give your answer in third form. How would I find y here, Edel? Yeah, how would I find it? What would I use to find it? Pythagoras theorem. Can I use it here? Well, I have two sides. I'm looking for a third. What does third form mean, Edel? Square root. Give your answer. It'll be y is equal to, for this one, it'll be y is equal to square root of 10, I'd say, is the answer for that. Okay, that one shouldn't be there, sorry. Oh, here. This is such a stupid question. Two members of soccer club want to find out if their football pitch has been lined up properly. They have a 10-metre tape measure, a calculator and a pen and paper. By only using these, explain how they could test if the angle at each corner is the right angle. Any ideas on this? This is a hard question. Sorry? No. No. Let me... Damn it. Not what I want to do. Where's the error server? Right. So what we have a 10-metre measuring tape, okay? Okay, let's pretend this is the football pitch, right? What you would do is, you'd measure from here to here, and that will measure out there. Okay, this is kind of the magic triangle, this one. 3, 4, 5. All right angle triangles are based on this one, okay? This is always a right angle triangle. Why is that? Because if I do hy squared is equal to adjacent squared plus op squared, that's equal to, so this is my hy. I'll just pretend this is my angle, so this is my opposite and this is my adjacent. So hy squared is equal to 5 squared is equal to 3 squared plus 4 squared, that's equal to 25 is equal to 9 plus 16, 25 is equal to 25. What did I just prove there? That this is a right angle triangle. And that's kind of like the magic triangle that every triangle is based on. So what you would do here is you'd measure out here 3 with the meter tape, yeah? You'd measure from here to here 4. And if you measure from this point to this point, what should it be? 5. And that's how you prove it's a right angle triangle. If you want to scribble that in, Are you okay with that, Edel? Yeah. It's not a great question, is it? Sorry. Right, okay. Next one there on the list. Have you finished that? Yep, okay. Next one there. Construct a right angle triangle ABC where AB is equal to 6, ABC is equal to 90. Okay, see these things here. What do these things mean? Angle. What do these things mean here, Edel? The top one there. Yeah, they're talking about the side. What angle are we talking about here, Dylan?
B.
Angle B. We're always, if you want to ignore that, it's always the middle. Whatever in the middle is the angle we're talking about. And angle AC is equal to 10. Would you be able to do that there? Do you know how to do it? Do you know how to do it?
Yeah, but draw that in 6 centimeters.
Oh yeah. No, not in the paper I gave you. You'd need compass and stuff for that as well. Right. On your diagram, measure blah blah blah. Let's draw in there. Let's do that. Okay, I won't do that one. So then there's some questions on that. Madison draws the scale diagram of the triangle OAB shown on the right. She marks in the angle X. She recall that AB is a metal bar which is part of the frame of the swing. So AB, where's AB? I'm on this side here. Where's AB, Edel? It's all that fella there. Yeah, that line. Write down the value of tan of X and hence find the size of the angle X. Okay, do you see what we did here all today? It's either Pythagoras theorem, silly old Harry, or silly old Harry. One of them you're finding a side, the other you're finding an angle. They're the only three things here. And they're even telling you what to look for here. They're saying tan of X. Tan is equal to what? Silly old Harry caught a herring trawling off America. So it's opposite over adjacent, which is 5 over 4 here. Yeah. And what am I looking for? I'm looking for a side or an angle, Edel? Angle. So what button do I think you're doing? Shift and whichever one, tan. See this fella here? Angle. What's this? Angle. Write down the value of tan of X and hence. Oh, sorry, that's X. Oh yeah. What does this mean here?
That's when you put it in.
Yeah, that's the answer. This just means, if you want to write it in, that just means angle X. It's just a fancy way of saying angle X. In order to increase the height of the swing, it is decided to increase X by 20%. The distance AB will be kept the same. Find the new height of the swing. Okay, what are they talking about here? Okay, what you have all the tools to do stuff like this. It's just to try and figure out what they're asking for in the question. Page below. Right, so what are they looking for here? In order to increase the height of the swing, it decided to increase angle X by 20%. What's going to happen to... Okay, I'll draw it out here on the next page. Okay, so I have a triangle here. Would you agree with this? 5 and 4. Yeah, you'd agree with that. Can we just pretend X is equal to 30? Pretend we worked it all out and X is equal to 30. Yeah? Will you go with me on this? Okay. What are they planning on doing? They're planning on increasing X by 20%. So what's going to happen here? X is going to, so that's 30. It's going to go up here higher. Do you see that? Yeah. So this will be my new X. This will still be, the length will still be the same. What will change here? 5 and the 4. What will happen to 5? Will it be bigger or smaller?
Long.
So it's bigger. What will happen to 4? Shorter. Just be aware of stuff like that. What does it say here? They were increasing it by how much? 20%. So how much will they increase it by?
That's 36.
Is it 36? 30, 25. Yeah, 36. So we get, you okay with that, Edel? 30 by, what was it, 20%? 2 is equal to 6, and then it's 30 plus 6. Right, so then this will be 36. If I go back here. Okay, so what do I, can I use Pythagoras? Okay, go away with that. Can I use Pythagoras' theorem on this?
No.
No. Why?
We only know AB.
We only know which, sorry? AB.
Yeah.
What did the question say? AB is going to be the same, isn't it? So I have to find AB before I go on to this one. Have I lost you on that? Brianna, have I lost you?
No.
How will I find AB here, Edel, on this triangle? Remember, there's only 3 things. Either Pythagoras' theorem, Silly old Harry looking for a side, or Silly old Harry looking for an angle. Sorry, no, how would I find AB here on this one? I know I'm throwing this on you now. What would we use, gentlemen?
Pythagoras.
Pythagoras' theorem here, Edel. Are you with me? Why? Because I know 2 sides and I'm looking for a third. Okay, I'll move on to the. I'm just trying to help you with this, and hopefully, I want you to try and do these yourselves anyway. This question: is it possible to make an object a soft triangle? That's a lot of reading there. Go to a picture like this. Leaning Tower of Pisa is 55.863 meters tall and leans 3.9 meters from the perpendicular as shown below. The tower of the Sunherzen Church is northwest Germany at 23 points tall and leans 2.47 meters from the perpendicular. By providing diagrams, I might get you to do this one. By providing diagrams and suitable calculations and explanations, decide which tower should enter the Guinness Book of Records. Okay, so in all these questions, we're looking for what? We're looking for a picture. Let's not worry too much about the story. Let's just see, we're going to end up with a triangle, aren't we?
Yeah.
Okay, so will you just have a quick read through that and see, I'll come back to you in a second, see if you understand what they're asking. Remember, there's only 2 things really we can be looking for. We can either be looking for the side of a triangle or some angle of the triangle. We just have to figure out which one it is.
And you both right hand triangle.
Yeah, because it's talking about the perpendicular. Do you know what perpendicular is?
Yeah.
Yeah, it's a line at a right angle. Okay, tell me if you think of anything or if you see anything. Or see what they're looking for.
Could use Pythagoras because we've got 2 sides of the triangle.
Okay, what's the... Yeah, we could. It mightn't be the right thing to do, but we could. What are they looking for? By providing diagrams, suitable calculations and explanations, decide which tower should enter the Guinness Book of Records as the most tilted tower in the world. Okay, if you're thinking about tilt, what do you think they're asking for?
Lean.
Yeah, are they asking for a side, the length of something, or an angle of something? Would you all agree with that? Adele, would you agree with that?
Yeah.
You sure? Yeah, Brianna?
Yeah.
Yeah, they're talking about tilt. So, I'll do this one here for you. So let's get the 2 pictures of the triangle out, okay? So let's do the Leaning Tower of Pisa. Did any ever go to it? Huh? No? Okay, so this is 3.9 meters from here. How tall is the Leaning Tower of Pisa? It's 55.863 metres tall. But that's from here, from the bottom of the tower to the top. So really, it's from here, isn't it?
Yeah.
What is it, 55.863? Would you agree with that? This is a right angle triangle because it said it's perpendicular. As shown. Yeah, so what do we want to find here for this triangle? What do we want to find really? The tilt, isn't it? How would we find the tilt there, Edel? What do you think tilt means here in this question? Are we looking for a side or looking for an angle? Or are we lost altogether? Are any of you lost? Oh, are you sure? I'll go over something if you are. So to see this tower here, Edel, I kind of took that triangle and I drew it here. Can you see that? Yeah? So we're looking for the tilt of that. So what do you think, what angle are we looking for here, Edel? I think we're looking for this angle or this angle? This fella here, is it? Yeah. So let's look for that angle. Right, now let's do our checks. Okay, what do you find the hardest about this? Is it the question?
Yes,
Understand what they're looking for, yeah. Are you okay once you get to here, do you think?
Yeah.
Right, okay. Can I use Pythagoras theorem here, Dylan?
Yeah,
To find
we're
A.
not looking for A.
Yeah, we're not looking for A. Do you see that, Adele? I can use Pythagoras theorem, but what would that give me, Adele? No, it'll give me this side here, and I'm not really looking for that. So then who do I look to? Silly old Harry. Okay? I'm going to write out what do I know, what do I want, that'll give me my formula. So let's label it. This side here is always called my what? This is the angle, so this side here is called my opposite, and this must be my adjacent. What do I know here in this triangle? Well, I know, what do I know? I know my hypotenuse, don't I?
Yeah.
And I know my adjacent. What do I want? Angle. And that'll give me my, sorry, no, we're writing crap this, that'll give me my formula. So it's going to be silly old Harry caught a herring trawling off America. Which one of these will I use, Edel? Cos, yeah, you're right. Cos. So cosine of A is equal to adjacent over hypotenuse. Let's fill in for what we know. Cosine of A is equal to adjacent, which is what, Brianna? 3.9. All over what, Dylan? 5.863. Be careful. Are we looking for a side or an angle here? Angle. So what button do we think it will? And this is how we write it down. You'd say A is equal to shift cosine of all this. And you work that out. You okay with that?
Yeah.
Right. Let's do the other side. Go back. Right. So that'll give us one angle. Then here, this other one. The Tower of Sonnenhausen Church, now we've heard it, Northwest Germany, is 27.37 metres tall and leans 2.47 from perpendicular. Will you just draw out that triangle now? What do you think that one is? Have I lost you at all? Are you still with me? You'll have to, the important things are to know when can you use Pythagoras, when can you use silly old Harry, when can you use silly old Harry to find an angle. You just have to know them. And then just try and interpret the question to try and make sense of it. You have to use a bit of common sense. You just move your hand here, Fiona? Yeah, okay. I know it's only a really small thing, but this is kind of like, which way is the lean? Is it leaning that way or that way? Which way? that way. So we should just try and draw it the same, so you don't confuse yourself.
Okay.
Just try and draw it the same way as Lena. You okay with that? How high is it? How tall is it? Yeah, we'll leave that. 27. Yeah, 27 by 27. It's 2.47 feet by Yeah. So, yeah, I know. It doesn't matter if you don't finish it. Like you're all in the right direction. Which one? Okay. Which one would break the record? Whichever is it the one that has the biggest angle or smallest angle?
Big star.
Small.
Adele, what do you say?
Small.
Smallest. Because Dylan, look, the smaller the angle, the
Yeah.
the more it leans. Does that make sense?
Yeah.
Yeah, sorry, Brianna, the smaller the angle, the more it leans. So stuff like that you just have to kind of make sense of. You have to use a bit of common sense in that. Are you okay? That's what all this project maths is about. Right. Let's see what else. In the right angle triangle shown in the diagram, one of the acute angles is 4 times as large as the other acute angle. What the hell is an acute angle? Good looking one.
Smaller than 90 degrees.
Yeah, smaller than 90 degrees. Find the measures of the 2 acute angles in the triangle. Any ideas how to do this? Brianna? Dylan? Adele? Okay. One of the angles is 4 times as large as the other. Okay, if I don't know something in math, what do I call it?
X.
Let me call this angle x. Okay? If that's x, the other fellow was supposed to be 4 times bigger, wasn't it?
Yeah.
4x. Yeah? Now, how many if I add up all the angles of the triangle, what should it add up to? 4x plus x plus what? 90 equals 180. Good. That's 5x. These are the things, yeah. 5x is equal to 180 minus 90. 5x is equal to 90. X is equal to 90 divided by 5. I know how 90 divided by 5 is equal to once and 18. No,
Yeah.
18. X is equal to 18. You okay with that?
Yeah.
So we're always, if you don't know anything in maths, in any question, not just this, we all call it x. And was that easy enough once you got the hang of it? Yeah? Right, let's flick through another one. The triangle of coordinate lines, the base is parallel to the x-axis. Find the slope of the line L that contains the hypotenuse of the triangle. What is, I think I'm missing a bit of this question.
That's part 2.
Yeah, I'm missing just something. Is it this one?
That's part.
That's part 1. I think it's the same question actually.
Yeah, it's the same triangle.
Oh yeah, the triangle in part 1 is placed on it. Yeah. Okay. Find the slope of the line L that contains the hypotenuse. What does slope mean? The degree. Sorry. Yeah, find means the angle. Do we not just find the angle up there? 18. Is that not what we just did? Look, is that not what we just did here? Do we not just, is that not the slope of that line? Slope of the line is what? Rise over run? Is that what you said?
Yeah.
So maybe what they're looking for you to find this side and to find that side and then put the rise, which is that, all over the run and get your angle. I'm not sure. That'll be interesting what you come back with on that one. Okay, let's see what else here. Do you see how they're all giving some crappy stories and you just have to try and make sense of them, Adele, and just all you want to get out at the end of the day is a what? That's a triangle. a triangle. All you want to get out of the end of the day is a triangle. And either are they looking for the angle or are they looking for the side? Okay, what about this one? triangle ABC, AB is equal to 2 and BC is equal to 1. Find AC, give me your answer in third form. Okay, we've seen all that before, just fill in 1 and 2, and I think it's Pythagoras theorem. Write cosine BAC, write cosine BAC and hence find BAC. And find, oh yeah, what are they asking for there? So this is all stuff we did. It mightn't have been the same way we did it, but they're still asking for the same stuff. So let's say this is my triangle here. I actually go some. Let's say that's my triangle there. A, B, and C is 90 degrees. AB is equal to 2. BC is equal to 1. And they're saying find AC. How would we find AC here, Edel? There's only 3 ways. There's only 3 things we need to know. That's Pythagoras theorem, Celia Harry to find a side, or Celia Harry to find an angle. Pythagoras theorem, yeah. And then they're saying find BAC, find cosine of BAC. So which one are they looking for, Brianna? They're talking about angle what, Dylan? A. So what they're really asking for there is, what is cosine of A? Right, so they're talking about this angle. Cosine, we go back to silly old Harry, caught a herring trawling off America, yeah? Which one of them is cosine? Well, it's this one, yeah? So cosine is equal to adjacent over hypotenuse. And all we do is fill that in from the triangle, which is, we'll find adjacent in the first part of the question over hypotenuse, which is 2. And that's all they want for that question. Are you with me? Yeah? Dylan, Adele? And then hence find angle BAC. So what are they asking you to do there then? Actually, they're actually asking you to work out A. And what we learned there today, we learned that if I'm looking for an angle, who do I think of on the calculator? The shift key, yeah. So I'm looking for a side, it's just normal. When I'm looking for an angle, it's the shift key. You okay with that? Right, okay. Well, this thing here, do you ever see this thing, angle theta? Do you ever see theta?
Yeah.
It's just like X or A or anything. It's just like X. Treat it as X. It's nothing new. It's just X or something. You okay with that? And just a few more questions there. Would you have a go at? Yeah. You just have to practice them. And if something comes up that you don't know, throw it on the Facebook page. This one looks boring, to be honest. But give it a go anyway. You okay with that? Right, I'll let you go with that stuff for today. Did you find that useful at all?
Yeah.
You just need to practice loads. Unfortunately. And remember the themes: Pythagoras theorem, silly old Harry looking for a side, or silly old Harry looking for an angle. You need to know them off the top of your head when you can use them. So you need to know, can I use this rule? Can I use that rule? There's only the 3 of them, yeah? Right, okay. Stop recording.